vectors in 3 dimensions. A quick recap on 2-dimensional vectors first. So point A with coordinates 3, 2, point B with coordinates 7, 8, and the vector P takes you from A to B. So we can write vector P as A to B. So P is in lowercase, these letters are uppercase. So in column vector form, we're going 4 units in the x direction, from 3 to 7, and then we're going 6 units up in the y direction, from y equals 2 to y equals 8, 6 units. And we can write this in component ij form as well, so 4i plus 6j. And then the length of this line, or the magnitude of the vector, given by Pythagoras' theorem. So using the x and y components for the vector, we have 4 squared plus 6 squared. We square root that, root 52, or simplified to 2 root 13. That's the length of this line here, or the magnitude of vector p. And then a unit vector in the same direction as vector p. So it's vector p divided by its magnitude. So there's vector p, 4i plus 6j, and I'm multiplying by 1 over its magnitude. So this is a unit vector, so it has a magnitude of 1, but it still points in the same direction as vector p. Vectors in 3 dimensions. So a unit vector in the x direction, in the positive x direction, is a displacement of 1 unit along the x-axis, and then nothing along the y-axis or z-axis. So vector I is 1, 0, 0. So vector j, 0, 1, 0, and vector k. So no displacement in the x and y directions, but a displacement of 1 unit in the positive z direction. Okay, so we can convert from component ijk form to our column vector form very easily. So for instance, this vector here in column vector form, so we need an x component, 5, we need a y component, and there's nothing here, there's no j term, so that will be 0, and we need a z component, so that comes from here, that's 3, so 5, 0, 3. So this vector and this vector are identical. And we can go the other way around as well, from column vector form to our component ijk form, so 2i minus 5j plus k. Okay, so in this example we are given coordinates in 3 dimensions for points A and B. We want the vector that takes us from A to B. So we can do that in column vector form. So I could say from x equals 1 to x equals 0, we're going in this direction from A to B. So from x equals 1 to x equals 0, that displacement would be minus 1. And then from y equals 5 to y equals minus 3, so there's a displacement of minus 8 in the y direction. Then in the z direction, we're going from minus 2 to 7, we're adding on 9. And we can write this in component ijk form, so we've got minus I, minus 1i, minus 8j plus 9k. Okay, now we're looking for the magnitude of our vector AB, so we just take the x, y and display. So now we're looking for the magnitude of our vector AB. We take the x, y and z displacements, we square them all. This is just Pythagoras' theorem in 3 dimensions, so each one squared, and you add the terms, and then we square root, and then we simplify. Now this is giving the wrong answer, even though it looks correct. I haven't put brackets around the negative numbers here, that's why the answer here is wrong. So this is now correct, and the answer is root 146. Now to work out the unit vector of AB, we're going to use this formula, and in the formula we can see that we need our vector AB, which is right here. So if I take that vector, let's put that in brackets. So that bit's done. Now I need the magnitude of my vector, which is here, root 146. But I'm not multiplying by it, I'm dividing by it here. So instead of dividing by root 146, I can write that as 1 over root 146. Yeah, it looks more convenient to have it like this rather than dividing the whole thing by root 146. So this is a unit vector, so it has a magnitude of 1 and it's in the same direction as vector AB.